Hello everyone, my name is Jingya. I'd like to present my milestone 1 today. I will divide it into 5 parts. First is introduction, second is the purpose of the project, third is the related work, fourth is proposed work, and last one is deliverables. For the introduction, nowadays, thinking computationally was a fundamental skill for everyone, not only for computer scientists, but also in non-CS people such as management engineer, mathematical scientists, physics scientists, chemistry scientists, and so on. With the development of computer process, computer thinking, which builds on the power and the limits of that, is more and more important. In education, computational thinking is a set of problem-solving methods that involve impressing problems and their solutions in ways that a computer could execute. The enthusiasm and growing initiatives for making programming to everyone induce the phenomenon that more and more non-CS students begin to learn computer programming skills like computer languages and algorithms. Some of them are mandatory by their universities, like Georgia Institute of Technology has gone as far as requiring all non-CS majors to enroll in at least one programming course to satisfy graduation requirements. While most of these non-CS students would like to learn programming for several reasons or related to their own future career, such as learning programming skills can improve their technical conversations. National Science Foundation NSF investigated a program on the year 2007 with 4 proposals. The goal of the NSF proposal is to increase the number of students developing computational thinking competencies by infusing computational thinking learning opportunities into education, not only in computer science study, but also in other non-CS fields of study. So in this project, there are 3 purposes of that. First, I like to investigate the current situation of natural science, non-CS fields with the development of computer science. Third, I like to figure out how important it is for non-CS students in natural science majors to learn computational thinking and computational programming. Third, I like to conclude some tools that existed can help students who major in non-CS fields to learn computer programming better. Next is the related work. Computational chemistry is a branch of chemistry that uses computer simulation to solve some chemical problems. They combine the theoretical chemistry method with efficient computer programs to calculate the structures and properties of molecules and solids. It is very necessary because computational results can in some cases predict unobserved chemical phenomena, like it can predict some phenomena that in the finite temperature. It also can reduce the materials waste for the environmental friendly, as shown in Figure 1, which is an example of computational chemistry application, 3D printing. 3D printing will create new industries and professions. The global economy and geopolicy will also be affected due to the 3D printing. The figure here shows the weapon manufacturing of that. Computational physics is a study and implementation of numeric analysis to solve problems in physics. Historically, computational physics was the first application of modern computers in science and is now a subset of computational science. MacDonald and his colleagues studies the impact of introduced beginning students to programming at the start of traditional physics course 1988. There are many computational physics methods like root finding, which can be used for Newton-Raphson method, system of line equations, which can be used for LU decomposition, and so on. All these methods are used to calculate physical properties of the modern systems, which is very helpful for physics problem. Figure 2 is an example showing a spacecraft crossing near a stationary Earth and the stationary moon, coded by a physical student. Computational biological involves the development and application of data analytical and theoretical method. Mathematical modeling and computational simulation technology to the study of biological, ecological, behavioral, and social systems. Rachel and his co-workers published a paper on 2009, which indicate the importance of computational programming in bioinformatics. More and more biologists are very interested in creating different tools to study this field, especially the approaches to analyze large gene lists. Computational mechanics is a discipline concerned with the use of computational methods to study phenomena governed by the principles of mechanics. Computational mechanics is interdisciplinary, actually 3 pillars that are mechanics, mathematics, and computer science. The P. Regers and G. Zeverois reported on 2014 that modern technology used to solve contact problems within computational mechanics. Figure 3 shows one example of computational mechanics modeling of fraction and moving boundary problem. For these 4 non-CS fields, how important it is for students to learn computational thinking and computational programming, and what is the effect about them after they are graduating and getting a job. It is very interesting to investigate, I think. For the proposed work, according to the introduction and related work, I like to focus my project on these 4 non-CS fields, which is physics, chemistry, biology, and mechanics. Each field I will answer 3 questions by reading paper and do some survey on the website, and questions are as following. First, is there any change of the field after conducting computer science? What is the benefit? Second, how important it is for students to learn computational thinking and computational programming skills during their study on campus and on job replacement. Third, is there some tools and platforms that existed can help students who major in non-CS fields to learn computer programming better? Next is deliverables. The milestone 1 due to today, the milestone 2 due to July 5th, and project presentation and the final project due to July 29. And I also made a survey to investigate the effect of computer science for non-CS fields on the website. If you have time, please help me to do this survey, and so that I can learn the project better. Thank you very much. If you have any questions, please give me the feedback.